that you haven't done before. Okay? So we're going to solve this equation. And what we learned up to this point is that when you solve an equation with an x squared, that you get it equal to 0 and you factor it. Well, that's not going to work on this question. I could get it equal to 0, but you would have no idea how to factor this question. Okay? It wouldn't factor, actually, technically. Okay? So, we're going to learn a new method. We're going to learn something called the square root method. So this is going to be a good segue to Goal 11 because it's actually the first thing that we expand on in the next chapter is the square root method. Okay, so we're going to solve using the square root method. I can use the square root method only when I have a square term, also known as a quadratic term, and a linear term. Nope, wrong. Constant term, which is just a number. Can't use it if there's an x, a linear term. So when I have a quadratic term, an x squared, and I have a constant term, a number, this is when I would apply square root method. And I would do this every single time. Okay? So before I finish this question, let me go back and show you why it works. Okay? So remember when you had something like this. Don't write this down, just watch me. Remember before when you had something like this, and we would get it equal to 0, subtract it, and we would factor it. This was a difference of squares. So we'd have x times x and 3 times 3 and plus and minus. And we'd get two solutions. We would get positive 3 and we would get negative 3. Give me just 1 second. Positive 3 and negative 3, because we used our shortcut and did opposite, negative 3 over 1, positive 3 over 1. Some of you were like, oh, I don't remember doing that. It was last semester. We did it, okay? But the square root method would say this. Isolate the x squared, get the constant here, and then square root both sides. So the square root of x squared would be x. The square root of 9 would be 3. And then I'd have a plus minus on that when you square root. So I'm getting the same two answers in a different way. We're going to use that method because like this one I'm doing right now wouldn't factor. It doesn't have a square. The number, we're going to have the number, what are we going to have? 13, which doesn't have a square. Okay? So that's why the square root method is applied. Sorry, another interruption here. Right now? Okay. Will you just wait out there for a minute? Okay. Okay. You're supposed to go ahead and put on the guidance right now. Okay. And I'll finish the things that you do. Okay. So go ahead and go down the guidance. Let's not take your stuff with you. Okay. So I'm going to add 10 to both sides. Two x squared equals 26. And then I'm going to divide by 2. So x squared is 13, which I've written, and it's delaying, which means it's probably going to shut off. Okay, and then I'm going to square root both sides. So a square root of x squared is x. The square root of 13, we can't take the square root out. We can't even break it up. So we leave it square root 13. But when you square root something, you always have the plus minus of it. So put that in front of that radical. So a while back when we began this Goal 10, the very first day, we had some questions where we had that little plus minus in front of numbers. That's where that comes from. Okay, so when you're solving a square root question, when you're square rooting, then you're going to get a plus minus. So plus and minus square root 13. This is where I should tell you that when you're working with an x squared question, you should really be checking your answers. But sometimes you don't have to. So let me do the next question, and then I'll show you why and when you don't have to. Questions on that? I was interrupted twice during that problem. So we didn't have a lot of consistency there. Question. Okay, let's look at the next one. Isolate the square root. It is. Square both sides. When I square the square root, you get what's underneath. And here's where we're going to have a problem right here. 3 minus x squared means I'm going to have to FOIL. Some of us are still not doing that because it's a quantity, it's a group. So that's a write it again and FOIL it. Oops. So first times first is 9. Outer times outer minus 3x. Inner times inner minus 3x. Last times last positive x squared. So I get, when I collect my like terms on the right side, negative 3 and negative 3 minus 6x plus 9. I continue solving. My x squareds cancel each other out. My 9s cancel each other out. And I'm left with 0 equals negative 6x. And then I divide by negative 6. Divide by negative 6. And x is 0. And it works, and I'm going to come back and talk about that in a second. Okay, and on my last example, I think that's my last one, yeah. Isolate that radical, so add that 2x first. Square both sides. So the square root squared gives you what's underneath. And on the right side, 2x times 2x is 4x squared. So we have a squared term, a quadratic term, and we have a constant term. That's when you use the square root method. So I'm going to subtract my 11x squared. So when you use the square root method, you get the constant to one side and your squared term to the other side. Divide by negative 7. And square root both sides. This is a perfect square. Square root of 9 is 3. And again, I have the plus minus of that value. Okay, so let's talk about, for a second, when something's not going to work. When something's not going to work. Okay? If you look at this one up here on the right, if I take the square root of 13 and I plug it in this equation, I'm going to get the exact same thing when I plug in the negative square root 13. Exactly. Because I'm putting it here. And when you square something, it becomes positive both times. So if I take a positive square root 13 and square it, I'm going to get 13. And if I take a negative square root 13 and square it, I'm going to get 13. Okay? So that's going to work either way. Because when I square positive or negative, it's going to work. What's different about this question and this question, if you look carefully, is that this has a linear x. And then when I take a positive number and put it here, and a negative number and put it here, they're different. It's not going to be the same thing. It's going to be the same right here, but it's not going to be the same right here. Okay? So it's likely, in fact it's for sure, that one of these numbers is not going to work. So let's plug in 3. 3 squared, I'm going to do it in my head, or as I'm going to do it out loud, but you could just punch it in your calculator too. You could actually punch in square root. I mean literally a square root symbol, do 11 parentheses, 3 squared, 11 parentheses, close parentheses, squared, minus 63, go outside of that, minus 2 times 3, enter. Okay, use your calculator, it does all that for you. I'll just do it real quick here. 3 squared is 9, times 11, 99. Minus 63, I just lost what I was doing, 63. What am I at? Am I at 99? 3 squared is 9, times that is 99, minus 63 is 36, whose square root is 6. Minus 2 times 3 is 6, 6 minus 6 is 0. So the positive 3 works. But when I do the negative 3, it's not going to work. I'll still get 6 here, but it's going to be minus 2 times minus 3 is a positive 6. So that's going to be 6 plus 6, which is not 0. Okay? So, when should you check it? When you know it's not going to work, something's not going to work, when you have a square, a quadratic, and a linear. One of them is not going to work. Okay? This one, right above it, had a square term only, not a linear x, so they both worked. Because there's no negative or positive to worry about. Here, I only came up with one answer, so I know it works. I didn't get a double root, if you want to call it. That's not really called a double root, 2 roots. Okay? So on this last one, it's just 3, not the negative. Now, just so you know, there's not like major points off if you forget to tell me this, okay? If you don't eliminate the negative 3, I mean, don't panic, I'm not like all wrong then or anything like that, okay? But it's important to start knowing that when you solve, because you're going to hit more and more of this as you go through your math classes, that there are some things that don't work when you solve. So don't always think that your answer is your answer, okay? Question about that? Okay, your assignment is